Okay, so for 8b.6, we are going to learn and apply the three properties of logarithms. So the first thing that I want you guys to be aware of is that logs are just different ways to write exponents. So because logs are exponents, the rules for logs are the same as those for exponents. So we're going to start with the product rule. When you are multiplying the numbers inside the log, you add if we wanted to break them apart. So if I give you log base b, some base, of m times n, I can split that up into two logs. A log base b of m plus log base b of n. So if I'm multiplying two logs, then I can also, or two numbers, I can split them up into two logs and add. And that's just like exponents. When we're multiplying two exponents or two powers, we add the exponents. So for example, if I have log base 6 of 3x, 3x is the same as 3 times x. So I can break that up into log base 6 of 3 plus log base 6 of x. So it's just like rules of exponents. When you're multiplying, we add the exponents. So the second rule is the quotient rule. With exponents, when you are dividing, you subtract the exponents. And so the same thing is true with logs. If I have log base b of m over n, I can break that up into log base b of m minus log base b of n. So I can break it up into two logs that are being subtracted. Now, the order is important here. So whatever is in your numerator is going to be the first log. Whatever is in your denominator, that's what you are subtracting in the second log. So for example, if I give you log of 17 over 3, I can rewrite that as log of 17 minus log of 3. The last rule is the power rule. So in exponents, when you raise a power to a power, you multiply those. So with logs, when you raise to a power, you multiply the logs. So if I have log base b of m to a power of n, I bring that power right in front of the log, and I can rewrite it as n log base b of m. So I'm multiplying my power by the actual log. So for example, if I have log base 3 of y to the 4th, I can take that exponent and bring it in front and multiply it by the log. So 4 times log base 3 of y. If I have something like log of 4 is the same as log of 2 squared. So then I can bring the 2 in front, and that is 2 log 2. So those are our three properties of logs, and now we're just going to do some examples using them. So the first set of examples we're going to do asks us to expand the logs. So when expanding logs, that means I'm taking a log that's all squished together and I want to use my properties of my product rule, my quotient rule, or my power rule to expand the log as much as possible, stretch it out as much as I possibly can. And then as a note, sometimes you will have to use more than one rule. So number 1, I have log of 2 times x to the 5th. The first thing that I notice is inside my log, I have 2 times x to the 5th. So that's a product rule. So the first thing I'm going to do is I'm going to rewrite this as two different logs, log of 2 plus log of x to the 5th, because this is just two numbers being multiplied. But then I also notice that my x has a 5 attached to it, so that's the power rule. So I'm going to bring that 5 down in front. So this is going to be log of 2 plus 5 log x. And that's as expanded as we can get, so that's going to be our answer. Number 2, we have the natural log of 7x squared over y to the third. This is obviously a product, so I'm first going to use the product rule. So that's going to be the natural log of 7x squared minus the natural log of y to the third. And then I notice that in my natural log, I have 7x squared. Remember that squared is only attached to the x, so this 7 and the x squared are actually being multiplied. So I need to rewrite this natural log as natural log 7 plus natural log of x squared minus natural log of y cubed. And then I can use the product rule. I'm sorry, the power rule. So this is going to be natural log of 7 plus 2 natural log of x minus 3 natural log y. So in that case, I had to use all of my rules. In number 3, I have log base 3 of the square root of 9x. In a case like this, I did not give you any rule for roots because we can always rewrite square roots as exponents. So the first thing we need to do is rewrite this square root so it has an exponent. So this is log base 3 of 9x, and the square root is a power of 1/2. So now I have 1/2 in front of my entire, or attached to my entire log, so I'm going to bring the 1/2 in front. So this is 1/2 log base 3 of 9x, but this 9x can be broken up using the product rule because it's 9 times x. The only thing that you need to make sure you are aware of is that 1/2 was attached to the entire 9x. So when we break this 9x up, we need to keep the log in parentheses because the 1/2 was attached to the whole thing. So this is actually going to be 1/2 times log base 3 of 9 plus log base 3 of x. If the 1/2 was only attached to the x, we wouldn't need the parentheses. But because the 1/2 was attached to the entire log, we need to keep that log when we break it up inside the parentheses. Number 4, I have log base 2 of x to the third. So the only thing I see here is a product rule. So I'm going to bring that 3 in front, and that is a 3 log base 2 of x. And there's nothing else that we can do to expand that. So we are done. So let's look at going the other way. So now I'm going to give you logs that are in expanded form, and I'm going to ask you to condense them, meaning put them together. So when we are condensing logs, you want to try and squish it all together so it's all inside one log. So number 5, I have log base 3 of 5 minus log base 3 of 20. Because we are subtracting, that is quotient rule. So this is going to be log base 3 of 5 over 20 But 5 over 20 reduces, so you always want to reduce if possible. So that's going to be log base 3 of 5 over 20 reduces to 1 over 4. In number 6, I have natural log of 6 plus natural log of 4 plus 2 natural log of x. So the first thing I notice is that I have a power rule that I need to take care of. So I'm going to do that guy first. So this is natural log of 6 plus natural log of 4 plus natural log of x squared. And now everything is being added, so that is product rule. So when I'm squishing them back all together, I'm going to multiply. So this is natural log of 6 times 4 times x squared. So that all condenses to the natural log of 24x squared. Number 7, I have log base 5 of 4 plus 1/3 log base 5 of x. So I'm going to take care of that power first. So this is log base 5 of 4 plus log base 5 of x to the 1/3. And now they're being added, so I can multiply these together. So that's going to condense to log base 5 of 4x to the 1/3. Last one for this set of notes, we have 5 log base 4 of 2 plus 7 log base 4 of x plus 4 log base 4 of y. Every single one of these has a power. So the first thing I'm going to do is take care of those powers. So this is going to be log base 4 of 2 to the 5th plus log base 4 of x to the 7th plus log base 4 of y to the 4th. Now, everything is all together except for this addition, so when I condense it, that is product rule, so I'm going to be multiplying. When I'm multiplying all of these, I have a 2 to the 5th, which I can actually do. I know that 2 to the 5th is 32. So this is 32, x to the 7th, y to the 4th. So those are using your properties of logs to expand, which is taking one log and expanding it into as many as possible. And then condensing takes a really long log and or many different logs and then condenses them into just one.